10, 9, 8, 7, 6, 5, 4, 3, 2, 1.
Hello everyone, greetings from CADD International. Myself Nijesh Nandan. I'm corporate trainer from CADD International UAE division. So very happy to see you all once again. So today we have a presentation by our students from the mechanical side. So welcome to Renaissance for the month of September. So let us get into the presentations. So as we know, Renaissance is a platform to showcase the talent of our students. So here today they will be presenting their works. So for today's presentation, we have 6 participants. So all the works done today is under the guidance of one of our most young and talented trainers that we have, Mr. Shaheen Shah NK. Thank you very much, sir, for your guidance. So let us go into the presentations. So first we have Ayaz. So I would like to invite Ayaz for this presentation. Over to you, Ayaz.
Hello, my name is Ayaz Nawab, and today I'm going to demonstrate my project, which is the design of a propeller shaft assembly. So let us begin. Project idea. The project idea over here is to simply demonstrate a simple drivetrain mechanism via the means of a propeller shaft assembly. The image provided indicates what the project idea basically looks like. As we can see, we basically have an engine which will act as a power source, which transfers motion to the differential gearbox present located at the rear via the means of two universal joints which are connected through a drive shaft. The project methodology that is followed in order to design and complete this project is as follows. First, we begin with the design and assembly of a differential gearbox, after which we proceed with the design and assembly of a universal joint. Then we design the drive shaft, followed by the design and assembly of the inline 4-cylinder engine, which will act as the power source. And after which we go on to modify the shafts between each of these sub-assemblies in order to form spline slip joints so that all these sub-assemblies can be connected together, which finally ends up with the assembly of all the sub-assemblies in order to generate the project. So the project results can be highlighted in these three images, which I shall go on to elaborate on now. So as we have here, the first rendered image wherein we can observe that the whole project assembly from beginning from the left, we have two wheels connected to the differential gearbox, which is connected to a universal joint, followed by a connection to the drive shaft, which again is connected to a universal joint, and finally ending up with a connection to the power source, which is the four-cylinder engine. Here we have a front view of the project indicating the differential gearbox. And here we have a side view of the project indicating all the components from a side view. So here is an animation of the project. Now we have another animation which will highlight the exploded view. As we can see here in the exploded view, each and every component and sub-assembly will be separated in order to have a better understanding of the project. Now I would like to move on to SolidWorks to just highlight a simple demonstration of the motion of my project. So here we are now in SolidWorks. As we can see, we have our project ready, and I would like to highlight the motion and demonstrate it. So let us begin. So as we can see, we have the engine as a source of power, which in turn transfers the motion to the first universal joint, which then transfers the motion to the drive shaft, which transfers the motion to the second universal joint, and leading to the transfer of the motion to the gearbox that we have, the differential gearbox, finally ends up with transfer of motion to the wheels. So thank you for your time, and I would like to conclude my project here.
That was an impressive presentation. Thank you very much, Ayaz. And next, we have Arun for his presentation. So let us call Arun. So now, Arun, over to you now.
Hi, my name is Arun A. I'm a mechanical engineer. I recently completed a SolidWorks course from CADD International under the guidance of Shahin Shah sir. I'm here to show you a model I created using SolidWorks. It's a DC motor with push-pull-cut mechanism. Let me show you. This is the image shown here is the final assembly I made using the software, and these are the major components of a DC motor: a housing, back cover, armature with a commutator, a back cover bush, stator magnet, housing bush, end contact, and spacer. Uh, this is the assembly with the exploded view. For a clear picture, I will show you that in the software itself. This is the final image of the DC motor I created using SolidWorks. Let me show you the interior of that structure. Okay, this is the interior structure with the armature coil and other components within inside. And let me turn this armature coil. Okay, you can see that this is how the motor works. And let me show you the explorer view. Okay, you can see that this is the housing, these are the bushes, anti-contact, and the stator magnets, spacer, and the armature coil. Okay, let me show you the cutting mechanism. These are the parts of the push-pull cut mechanism. It's mainly of a rocker arm and a Genevier mechanism and the spur gear required for it. And these are the guides which keeps the things in correct position. And this is a knife which is used for the cutting mechanism. And this is the structure of the final assembly along with the DC motor and the push-pull mechanism. Let me show you that in the software itself. This is the final mechanism that we get after the complete assembly. And let me show you the working. And when we rotate it, it will just move like that, and we can see that the knife is moving up and down, and it is a push-pull mechanism itself. Okay, let me show you the explorer view. This is the explorer views of the component I assembled using SolidWorks. Okay. Okay, thank you. Thank you for your valuable time, and I am very much thankful to CADD International and Shaheen sir for the guidance and the support that they provided. Thank you.
Thank you, Arun. That was a good presentation by him. And for the next presentation, I'm calling upon our next presenter, Mr. Jeffin. So now over to you, Jeffin. You may start presenting now.
Hi all, my name is Jeffin John. I have completed my course on SolidWorks from CADD International. For the completion of my course, I will have to submit my project based on the SolidWorks modeling. I have completed two different differential gearboxes using the SolidWorks version 2020. This is the standard differential gearbox, and this one is called the advanced differential gearbox with the worm gear assembly. Differential gearboxes are an integral part of the automotive world. It helps in translating the power from the engine to the wheels and prevents the vehicle from dragging its tires while taking a turn. This is actually the rendered image of the SolidWorks model that I have created. Now let's take a look at the SolidWorks drawing that I have created. This is a 3D model of the standard differential gearbox that I have created. I have given some gear names so that the motion of the gears can be analyzed. Now let's go to the second model, that is the advanced differential gearbox. This is the advanced differential gearbox, Uh, this is the 3D rendering of the advanced differential gearbox. Actually, the vane gears are used when we have to reduce the speed to a large extent. For one rotation of the vane gear, only 2 or 3 mm movement of this gear is actually possible. These two are called the spiral gears. These are two axis movement, one on this one and the other one on this one. We can see that while rotating this, the movement of the spiral gears we can identify that the two gears have two axis movement on it. I have created this two axis movement by giving an unbalanced weight while giving the gear mate. Thank you all for watching my presentation. I would also like to thank Mr. Shahin sir for all the support that he gave me during the course of my study. Thank you.
Thank you, Jeffin. Thank you for the presentation. So, the Renaissance Live, it was an initiative by CADD International as a part of Go Live. So far, it has been a successful event by the active participation of our students. So, on behalf of CADD International, I would like to congratulate and thank all the students who have participated till now for Renaissance Live. So, moving on to next presentation, we have with us Syed Kamar. So, I would like to invite him. So, Kamar, over to you now.
Hello everyone. Hello everyone. My name is Syed Khamaruddin and I am a mechanical graduate. First of all, I would like to thank CADD International for giving me this opportunity to present my work. I have built a mobile crane using a software SolidWorks. I have used this geometry as a reference geometry and I have kept the scale as 1:1. This model consists of several sub-assemblies such as the telescopic boom, hydraulic ram, hook assembly, tire assembly and the outrigger assembly. Let's look at them one by one. This is the telescopic boom assembly. This assembly consists of 3 number of booms and the pulleys which has the oscillating motion and the reciprocating motion. And this is the hydraulic ram which gives the motions, which has the to and fro motions and which gives the motions to the hydraulic boom. This is the hook assembly. This assembly consists of several parts such as the plates, the pulleys, the bolts, the bearing and the hook itself. This carries the load. This is the exploded view of the tire assembly. This assembly consists of the tire, the rim, the hub and the bolts. There are 8 tires in this assembly. This is the outrigger assembly. This is used when the crane is needed an extra support or when the load is high. This is the exploded image of the whole model which contains every part in the assembly. Other than the assembly, there are remaining parts that are the driver's cabin, the boom control cabin, the motor box and the chassis itself. This is the driver cabin which controls the motion of the automobile. This is the boom control cabin. As the name says, it controls the motion of the boom. And this is the motor box which has the motor which controls the hydraulic system of the boom as well as the hydraulic ram. This is the chassis itself to which all the other assemblies are tied together. This is the final model how it looks using the SolidWorks. Now let's look at the model in the SolidWorks also. This is the model and the tires are linked together like If one tire has the motion, then every tire will rotate. These outriggers have the motion like this, and this goes like this and touches the road and gives extra support to the mobile cable. And this is the boom, which has the reciprocating motion, which has 3 number of booms which moves among themselves within each other, and it also has the to and fro motion like this. Let's look at some of the rendered images which I have rendered using the software KeyShot. This is the left side view, the front view, the right side view, and the back view. This is the view with some scenery. So that's it, guys. In the end, I would like to thank Mr. Shainsha to be our mentor and help me in making this project. Thank you, sir.
Thank you, Kamal, for your presentation. So moving to the next presentation. So for the next presentation, we have Mr. Asif. Yes, Mr. Asif, now over to you.
Hello friends, my name is Asif. I am currently doing BTech in Mechanical Engineering from UPES Dehradun. So today I am here to present my final project after the completion of 1 month course from CADD International. So we can move to my model. So I have designed a RC drone also known as unmanned aerial vehicle or unpiloted vehicle, which can fly autonomously without the help of external action. RC means remote control drones. It can be controlled using remote by the user. Propeller in drones have two kinds of rotation. It may be anti-clockwise or clockwise direction. Rotor, which you have seen in drone, provide up and down motion to move the drone. The working principle is that the rotor pushes the air in the same manner air pushes the rotor back. In this way, the drone causes its motion. Drone have various kind of application in this generation. It can be widely used in agriculture sector, defense, aerial photography and videography, rescue operation, in forecast system and surveillance, etc. There are so many applications which can be found in drones nowadays. So now we can move to the parts which I have designed to assemble this drone. So these are the parts which I have used to assemble my drone. I have used more than 50 parts to assemble my drone. So here we can see battery, the top and base of the drone, and also the electric unit. Then we can see motor, fan, also camera, mount, also the drone leg. These are the parts which I have used to complete my model and assemble. So now we can move to my final view of the model. So this is my drone which I designed using SolidWorks. So now I will open this model in SolidWorks. So this is the model I am open in SolidWorks. I have created this by using only basic features in SolidWorks like boss extrude, revolve base, offset pattern, and etc. Now you can see the propeller is rotating. Now I will show the exploded view of the model. So this is the exploded view of the model. So now you can see the parts get delocalized from their original position. So I will show a short video how this explosion takes place. So this is the exploded view of the model. Now I will show how this explosion takes place by showing a short video. Here you can see the parts get delocalized from their current position and also getting back to their origin position. So now we can go for a short animation of my model in SolidWorks. Here you can see the animation. The drone is rotating in various plane. So hereby I am concluding my presentation. I would like to thank CAD International for taking initiative to provide training for engineering aspirants, and I would like to thank Shine sir for spending time with us and a wonderful learning from you sir. Also thanks all for watching this.
Thank you, Asif, for the wonderful work. Thank you for the presentation. And now we have our last presenter for Renaissance for the month of September. So I just like to invite Mr. Shahir for his presentation. Over to you now.
Hello everyone, I am Muhammad Shahir from Thrissur, Kerala. Basically, I am a third year mechatronics student at Malabar College of Engineering and Technology. I have completed my SolidWorks from CADD International under the guidance of Shane Sessa. I thank all of them for such a wonderful moment. I am here to present my SolidWorks project, Robotic Arm. We all know that a robotic arm is a mechanical arm which is usually programmable with similar functions of our human arm, with number of joints that can move along any direction or can be rotated at certain directions. So let's look at some rendered images of my project robotic arm. These are the different views of the robotic arm. Working of the robotic arm. In this mechanical part, it consists of 6 degree of freedom, 6 parts providing each 1 degree of freedom. Let's have a look at it. Okay, this parts provides degree of freedom in z-axis, and then next is along x-axis. and it's also along x-axis, and this partition belongs to y-axis, and it is also in x-axis, and the final it's along the axis, and these two clippers helps to hold the object. Let's go to the SolidWorks software. Here is a front view of the model. Let's look at it. Then back view, and then side view, both from both sides. Finally, the top view. It's look like this. The product will look like this. The robotic arm and the block using the feature tools, and the conveyor using weldments. Let's look the individual look of the robotic arm. This is the robotic arm. It consists of 9 parts, and these are the several parts. The base, this one, and next is this one, next this one. So screw. Then this is the individual photos of the parts. It consists of 9 parts, and that's all. Thank you all for watching my project, and once again I thank Shahin Shah and CAD International to including me in the CAD International family. Thank you.
Thank you very much, Shahir, for the presentation. And with that wonderful presentation, we come to an end of the presentation for Renaissance Live for the month of September. So I would like to congratulate all the participants today who have participated for Renaissance for the month of September. So these were the participants for today's Renaissance. I would like to congratulate all for the effort that they have taken. And from behalf of CAD International, I would like to thank you all for making this event a successful one. So the event would not have been complete without the mentioning of our trainer, Mr. Shahin Shahin K. Thank you, sir, for your contribution. So with that, we conclude our session for the month September. So soon we will be meeting you with another session of Renaissance Live. Thank you very much, guys, for joining with us. Thank you and have a good day.